Today we're going to talk about the natural number e. So what is e? E is an irrational number with an approximate value of 2.71828 ... Now, a lot of times we think of pi as roughly 3.14, but we know pi goes on forever and never ends. Well, e is very similar to that. It does have a different value. So normally what you need to do is associate 2.718 anytime you see the natural number e. So e often occurs as the base of exponential and logarithmic functions that describe real-world scenarios. So base e exponential functions. Exponential functions with base e are called natural base exponential functions. So for example, you may see f of x equals base e to the x power, or remember, you can take f of x out, replace it with y. So you might see y equals e to the x power. So basically what that is y equals 2.718 to the x power. Now, base e logarithmic functions. Log functions with base e are called natural logarithms. For example, you might see f of x equals log base e of x. This is often abbreviated as f of x equals natural log of x. So basically, if you ever see log base x of e, or log base e of x, you need to rewrite it as log of x. Okay, because there is an understood e right there. You won't ever see it when you see the ln, but that's the difference between log and natural log. LOG, the button on your calculator, is a base 10 button or logarithm, and natural log is a base e. Normally, you do not see either one of those. You do not see a 10 here or an e here. They're understood to be there. So we're going to write each logarithm or each exponential in logarithmic form. So now if you remember, when we did this, we said log base b of y equals to x. That's how we rewrote this. So now I'm going to do log, grab my base, e, log of base e of 24 equals to the exponent. Now, log e, I'm going to replace with natural log of 24. So that would be my final answer as a rewritten logarithm. Now, here, going to do the same thing. Log base e of x, grab your base, go across, and set it equal to the exponent 9. This comes out, and you replace it with natural log of x equals to 9. So over here, we're going to do the same thing with number 3. Log base e of 72 equals to x plus 5. This drops out, and we're left with natural log of 72 equals to x plus 5. Now, we're going to go backwards. We're going to write each one in exponential form. So in order to do this, you have to make sure you remember that there is a base e for every single natural logarithm. So to write it in exponential form, we want b to the x equals y. So grab your base, which is e, raise it to the 58th power, and set it equal to x. Grab your base, raise it to that power, so e to the x equals to 6. E to the 32 equals to this number, so x minus 9. So we have now rewritten exponentials as natural logs and natural logs in exponential form. So what we're going to do is we're going to talk about, I'm going to go back over the properties real quick, because what you can do with LOG properties, you can do with natural log properties. So if you have log of m times n, you can rewrite that as log m plus log n. Now, if I have natural log of m times n, I can rewrite that as natural log of m plus natural log of n. So the only difference between the two is that this is a base 10 scenario and this is a base e. You do not write those bases. When you have an ln or natural log or a common log base 10, you do not put the bases. So in the first example, I have a natural log plus a natural log. So I'm going to condense it to one logarithm and multiply the 3 times 16. And that gives me natural log of 48. Now, the second one, example number 8, actually uses the quotient property and the product property. So I'm going to go back over those and show you how they work with the natural log. So if you have m divided by n, remember we can take log of m and subtract log of n from it. So if I have natural log of m minus or over n, I can write that as natural log of m minus natural log of n. Now remember, these properties go the opposite direction. So if I have a natural log minus a natural log, I rewrite it as one logarithm with a fraction behind it. Now, the power property, that is when you have n log base b of x. That's when you can take the power, the multiplier, and write it as the power. Now I can do the same thing with natural log. I can take this number and I can rewrite this as natural log x squared. Now, when we do the powers, you have to remember that a fractional power, anything to the 1 over n power, becomes the nth root of whatever your base is. So in this problem number 8, I do have a multiplier. So the first thing I'm going to do is I'm going to use my power property to write that as an exponent. So natural log of 3 squared, which is 9. So I'm going to go ahead and simplify that. So natural log of 9. And then I'm going to write natural log of 63 divided by 9, and that reduces to natural log of 7. Now in this problem, I do have a fractional exponent, and I have a fractional multiplier and a regular multiplier. Fractional multipliers end up being radicals. But the first thing I'm going to do is I am going to apply the power property. So I'm going to take this, make it the power, take the 2, make it the power on x. So natural log of 64 to the 1/3 power plus natural log of x squared. This 64 to the 1/3 power becomes the cube root of 64, and the cube root of 64 is 4. So I've taken all of this, I've gone into some workspace, and I've ended up with natural log of 4 plus natural log of x squared. Now I'm going to use my product property to pull these two numbers back together using multiplication. So one logarithm with a 4x squared behind it. And that would be your final answer for that one. Now, when we expand logarithms, we are going to go in the opposite direction. So in number 10, I have natural log of 5 times x. So I can split the 5 in the x and have natural log 5 plus natural log of x. In the second example, I do have a power. Actually, I have 2 of them, but I take care of the outside power first. So 2 natural log of a to the 3rd over b. Then I need to split that. So I'm going to have 2 times the natural log. Let me write that a little bit better. 2 times the natural log of a to the 3rd minus the natural log of b. And then I have this interior power. So I have 2 times 3 natural log of a minus the natural log of b. Now, this is good enough for me, but MathExcel may want it extended. So you may have to distribute the 2. So that would end up with being 6 natural log of A minus 2 natural log of B. So if you type this into MathExcel and it says, don't want that answer, go ahead and distribute the 2 and try to type it in that way. And if you're still experiencing issues, please make sure that you let me know. Now, in this problem, I have a cube root. So I'm going to use my exponent property backwards. So this gives me natural log of m squared n to the 1/3 power. So if I have x to the 1/2 power, that becomes the square root of x. I can also go backwards, take a square root and make it x to the 1/2 power. So these go in cycles. So now I'm going to take that external power, put it out in front as a multiplier. So 1/3 times the natural log. Not really sure why I put that extra parentheses just yet. Natural log of m squared times n. Then I'm going to separate these two using the product property. So 1/3 natural log m squared plus natural log of n. Then I have that extra exponent that I have to deal with. So 1/3 times 2 natural log of m squared plus natural log of n. Now, I would be okay with the 1/3 being on the outside. So I would be okay with you leaving your answer this way. If you type your answer in this way and MathExcel does not want it, go ahead and distribute the 1/3. So you may have to type in 2/3 natural log of m squared plus 1/3 natural log of n. I cannot tell you which version that MathExcel is going to want, because sometimes it wants what's in the box and sometimes it wants what's under the box. So please make sure that you pay attention to that. Now, the very last thing that we have to do in our packet is we have to solve logarithmic equations. So we've already done log logarithms. Now we're going to solve natural logarithms. So if you have natural log of m equal to natural log of n, you set your m and n values together. But make sure that you remember these two values have always got to be positive once you get your final answer. So I have a natural log equal to a natural log of number 13. So I'm going to set this value equal to that value and just drop the natural logs. So 4x minus 27 equals to 15 minus 2x. If you add 2x, that gives you 6x minus 27. If you add 27, that gives you 6x equals to 42. And when you divide by 6, you get x equals to 7. Now, to check, I've got to plug 7 back in here and make sure that those numbers stay positive. So 4 times 7 minus 27 is 28 minus 27, and I do get a positive outcome, so I'm good here. 15 minus 2 times 7 gives me 15 minus 14, which is a positive outcome, so I'm good here. So I can keep the 7 as my answer. For number 14, what I need to do is my power property first. So I'm going to rewrite that as natural log of k squared equal to natural log of 2k plus 15. Now that I have a natural log equal to a natural log and I took care of my power property, I'm going to set this value equal to this one. So k squared equals to 2k plus 15. Well, that presents a quadratic, so I'm going to move both of these terms to the other side by subtracting them. So k squared minus 2k minus 15 equals to 0. Then I'm going to factor. Now, most of these, if they expect you to factor, they should factor. So factors of negative 15 that add up to negative 2 are negative 5 and positive 3. when you set each factor equal to 0. So k minus 5 equals 0. So I get one answer of 5. And k plus 3 equals to 0. And I get a second answer of negative 3. Now, I have to check both of these numbers, k squared and 2k plus 15, have to stay positive. So when I plug in 5 squared does indeed stay positive. 2 times 5 plus 15 will also be a positive outcome. When I type in negative 3 squared, or when I plug that in, negative 3, a negative times a negative is always a positive. And then I'm going to have 2 times negative 3 plus 15, and that will also be positive. So I actually get to keep both of my answers for this particular problem. Okay, now I am going to have to use my properties. Here I have a natural log or minus a natural log, so I'm going to have to condense that to one logarithm with a fraction behind it. That's how you rewrite a logarithm minus a logarithm. And when you divide 72 by 4, you get natural log of 18. Here, I need to pull these together with multiplication. So I get natural log of 6 times a minus 2, which would give me natural log of 6a minus 12. Now that I have a natural log equal to a natural log, I set my numbers equal. I add 12, that gives me 30. So I get a value for a, which is 5. Now, I need to make sure that this value, because it's the only number, I cannot plug in a here, I cannot plug in a here, I cannot plug in a here, but when I plug in 5 minus 2, when I check, does give me a positive answer, so I can keep my 5. All right, so for number 16, I do have a power, so I'm going to have to deal with that power. So I've got natural log of m plus 4 squared. I move that 2 by using my power property, equals to natural log of 4. Once I do this, I can drop the logarithms. So I'm going to have m plus 4 squared equals to 4. Now I have a couple of options here, and we haven't seen it done this way. I can use my square root property, but the only thing about using your square root property is most students forget the plus or minus. And then I can subtract 4, so plus minus 2 with a minus 4. So this gives me two answers, positive 2 minus 4, and it also gives me negative 2 minus 4. So I end up with negative 2 as an answer, and I end up with negative 6 as an answer. Now, as long as this value stays positive, I can keep those answers. So negative 2 plus 4 is a positive, and negative 6 plus 4 does not equal to a positive. So I'm going to have to throw out negative 6, and I can only keep negative 2 as my final answer. Okay, so in this particular problem, we are going to have to work this a little bit differently, because we are going to have to rewrite this in exponential form. So I'm going to grab e squared equals to 8x, grab your base, then your exponent, and then your number, and then I'm going to divide both sides by 8. When you type in e squared divided by 8, you should get 0.9236 as an x value. If you plug that in right here, 8 times a positive number stays positive, so we can keep this number. I am going to have to use my properties to condense this, so I get natural log of x divided by 9 equals to 7. I am going to have to rewrite this in exponential form. So e to the 7th equals to that fraction. Then I'm going to multiply both sides by 9 to cancel the denominator. So x is going to be whatever 9 times e to the 7th is. I suggest you type it in your calculator, e to the 7th, get that answer, and then take that answer and multiply by 9. Because sometimes students take that and they multiply the 9 and the e, and then they raise it to the 7th power, and that's not what should happen. So you should end up with an x value that is pretty big, 9,869.6984. All right, we have a few more examples to get through. So here I have e to the x equals to 57. So what I'm going to do is I'm going to natural log both sides. We did this with log log, so you can natural log both sides. Now, anytime you have e to the x or natural log of e to the x power, the outcome is just the exponent. So this drops out, and I end up with x equals to natural log 57. And that decimal number you should get is 4.0431. Before I can do natural log to both sides, I have to add 6. I need to get the b to the x by itself, so e to the y plus 3 power. The 6's will cancel, that gives me 30. Now I'm going to natural log both sides. This drops out and just leaves me y plus 3 equals to natural log of 30. And I'm going to subtract 3 from both sides. So y is equal to the natural log of 30, then subtract 3. And you should get 0.4012. All right, for the last two, in order to solve this one, I am going to have to divide by 5. So that gives me e to the 4n equals to 19. I'm going to natural log both sides. This will drop out and leave me with 4n equals to the natural log of 19. Then I will divide both sides by 4. So I get n equals to natural log of 19 divided by 4, and that should be roughly 0.7361. Number 22 has a lot of things going on. I need to isolate this part, so I'm going to subtract the 3 first. You always move numbers by adding or subtracting first. And then I'm going to divide both sides by 2. So that gives me e to the c minus 9 equals to 42. At this point, I will natural log both sides. That will cancel and leave me with c minus 9 equals natural log of 42. Now I'm going to add 9 to both sides. So that would give me c equals to natural log 42 plus 9. And I apologize for having to go up. My c value should be roughly 12.7377. And that would be your final answer. So if you have any questions about the natural number e, expanding, condensing, we've done a lot. If you have rewriting in logarithmic or exponential form, condensing, expanding, and the different variations for solving logarithmic equations with natural logs and base e, please feel free to contact me.